350 years before the birth of Christ, the Greek philosopher Aristotle wrote a manuscript about plants. He explained how trees grow by sucking food through their roots from the soil. You might well think that Aristotle and the Arab scribe who later penned this copy of his ideas gave an accurate explanation of the way trees grow. But if you did, you'd be completely wrong.
Most people believe that what you put into the soil goes into the plant. They'd be astonished if they thought that the vast majority of what goes into the plant actually comes from invisible gases in the air.
Aristotle never imagined photosynthesis. We now know that plants use sunlight to turn carbon dioxide gas from the air into solid material. Excluding water, only a tiny fraction of wood comes from the soil. Photosynthesis is just one of the fundamental scientific ideas that we spend time and money trying to teach. But it seems as though the science isn't being understood. This is the sort of place where you'd expect people to know how trees grow. It's graduation day at MIT, the world-renowned Massachusetts Institute of Technology near Boston.
We are the premier engineering and science institution in the world.
They think that all they've got to do here today is pick up their degrees and kiss a few distant relatives. But a team of researchers from the Harvard-Smithsonian Center for Astrophysics is armed with a film crew and intent on spoiling the party. They're here to put the graduates on the spot with some of the most basic scientific questions, such as, where does wood come from?
This is a seed here. You can take it in your hand. Now imagine that we planted that seed, and out of that seed grew a tree. And here, you can take this. Now, what did all that stuff come from?
Nature. In the ground, the soil, the grass, the dirt.
What would you say to someone who told you that the weight of the tree came mostly from the carbon dioxide in the air?
I would say that's very disturbing, and wonder how that could happen.
Came from carbon dioxide from the air? Oops.
It's an interesting idea.
Sounds weird.
Are you surprised
Yeah.
at that idea?
Yep.
That'd be hard to believe because carbon dioxide is, well, it's a gas, and it doesn't seem intuitive that you could add mass taking in a gas.
Uh-huh.
This came from a lot of things.
Watching graduates getting it wrong proved that even after extensive formal teaching, the most basic scientific concepts can fail to take root in students' minds. People start developing personal theories of how the world works from earliest childhood. They base these mental models on the way they themselves interpret their observations and experiences. Their interpretations are often wrong, but because the beliefs are their own, they can be very firmly held.
Every class starts off with students having conceptions about every major concept that's going to be covered. It doesn't matter what the field is. If it's an important idea, students will have their own conceptions coming in. To get to the next level, to be able to predict what happens in nature, to be able to design a computer or to study an ecological system, you have to get beyond your misconceptions. So for most kids, they don't get beyond the misconceptions, and the science doesn't make much sense to them.
John Federico is an ordinary boy, and it's precisely because he's an ordinary boy that his mind is full of his own personal theories about the world, each one a potential block to new learning. He was studied before and after teaching. Bob Holden, his teacher, was then confronted with the video evidence, starting with the tapes Harvard made before the lessons began.
Is this here? Is this mostly soil? Some parts. It's mostly a mixture of everything put together with what the tree started out with in the seed. It's all that. So put it together. Put all together the things where it started with, the soil, the water, and the sunlight, you pretty much get this.
What is it, do you think, that makes this?
This log put together is about 60% water, I'm gonna say. All right, sunlight. I'm gonna put 0% sunlight and about 40% soil, because as you can see, you know, there's lots of soil on the top, and I'm sure there's lots of minerals from the soil on the bottom. So I'm gonna say about 40% soil. And that makes up 100.
Thank you. I really appreciate it that you made it so clear and...
Before teaching, John's common sense tells him, quite wrongly, that everything a tree is made of comes out of the ground.
About plants.
Okay, well, that's I think he did some good thinking. I think that backyards would look a lot different if it was really true about all the soil disappearing. Could be a problem trying to generate all that soil. People would be bringing truckloads of soil into their backyards. And the fact that the gas is critical. Now, I hope the next tape shows that he does understand, but I don't know what it shows.
Well, the leaves of the plant absorb the sunlight, and it turns the sunlight into food it needs, and mixes it with the rest of the ingredients that it needs, and it uses all those great ingredients to grow and become a big plant.
Now, last time, I think that you told me it was made out of about 60% water and 40% soil minerals.
Yeah.
What would you say now if I asked you what that tree was mostly made out of?
60% water and 40% of the rest. Definitely. Now that I think about it even more, it's probably about 70 to 75% water and 25 to 30% of the rest.
And the rest is?
Oh, the bark and all the minerals and soil and stuff like that.
Still got the soil in there.
Yeah.
In one respect at least, Bob Holden's teaching has failed. John's personal theory remains, and carbon dioxide from the air doesn't even enter into it.
Well, let me just tell you something that some people think that that wood right there is almost completely made of carbon. What do you think about that?
I think they're wrong. There's no possible way that something that just came off of something that wasn't living could be just made out of carbon.
I don't know what happened. I tried to draw it together showing molecules, and we had studied molecules, and yes, there's the starch molecule, and it's turning into sugar.
Plants need energy too, right? So where do they get their energy from? The starch. From the starch they make.
I thought I made it clear.
From the sun to a plant, piece of cake.